Hello everyone, this is Dr. Surya. Today we are going to see about the basics of septic tank as well as a design problem in septic tank. First of all, what is a septic tank? So it is going to be an underwater sedimentation tank that is used for wastewater treatment. Mainly it is done by means of the biological decomposition. Okay, so because it is closed environment, anaerobic digestion is taking place actually. So it is very simple design, and otherwise we can call it as an underground watertight container. It will be mostly in rectangular in shape, and it can be made up of fiberglass or concrete. Okay, so there are some compartments in a septic tank, and normally you see that you are having a T-shaped outlet. So you can see the T-shaped outlet here. So this T-shaped outlet is provided mainly to prevent the sludge and scum that should leaving from the tank and traveling into the drain field area. So for that purpose only we are having a T-shaped outlet. Okay, so this septic tank, it will digest the organic matter and it will separate the floatable matter and solids from the wastewater. So floatable matter is something like your oil and grease. So this we call it as our scum. So this layer we call it as our scum, and this layer is called as your wastewater. So wastewater is segregated, and final part we call it as a sludge. Okay, and this will be your inspection tank. So both will be, so these two things will be your inspection pipe, and through which the inspection is carried out, and this will be our manhole. So this is going to be the very simple design of our septic tank. Okay, so you are having one inlet pipe. So this is going to be the inlet pipe. So through this inlet pipe, the wastewater will be transported from the house, and it is getting collected in the septic tank. So it is kept for some period so that your solid waste and liquid waste is going to be separated from each other. And second pipe, so this pipe is called as our outlet pipe. Okay, so through this pipe, otherwise it is called as your drain field. So from this all the wastewater can move out, and the top layer we call it as, that is the oil and grease layer, and everything will be floating, and that is going to be called as your scum. And the middle layer is called as your wastewater, where you have all your waste particles. And third and bottom layer, it will be very heavier than water, and they form a layer of sludge. So bacteria inside the tank, they do the work, that is they are breaking down the solid waste, and then it allows the liquids to separate and drain away very easily. And finally, if you see that all the wastewater can be removed, your scum can be removed, and only the sludge will be settled at the bottom. So this will be periodically removed, either once in 6 months or once in a year. This will be removed as a part of your general maintenance. Okay, so this is going to be the very basic form of our sewage treatment. Okay, now we'll move into the problem. So design a septic tank for on-site sanitation of a housing colony with 120 population. Assume suitability data. So this is a problem given to us. So what is given? So first, initially population is given. Population is going to be 120. Now what I am going to do is that we are going to assume our per capita rate. Quantity of water supplied will be population into per capita rate. Okay, so per capita rate into population. So here per capita rate will be 120, and population is also 120. So we'll be getting 14,400 liters per day. Now assume 80% of water supplied is becoming sewage. Okay, so assume 80% is becoming sewage. So quantity of sewage produced will be 0.8 times, that is 80 by 100, that is 0.8 into 14,400, which is equal to 11,520 liters per day. So this is going to be your quantity of sewage produced. Now you are going to assume your detention time. Okay, so assume your detention time as 24 hours. Okay, what is the detention time? So it is an average theoretical time that is going to be required for the sewage to flow through the tank. That we call it as our detention time. So now, what is the quantity of sewage produced during the detention time? We are going to calculate that thing. That is quantity of sewage produced during detention time. Okay, so which is going to be 11,520 into 24 by 24, because already this is liters per day. So we are and this is going to be in hours. So that is why we are putting a conversion factor of another 24. So that becomes 24 by 24. So which is 11,520 liters. So again I repeat, 124 is for our detention time, that is 24 hours. Another will be that the quantity of sewage produced is in liters per day. So one day will be equal to 24 hours. That's why we are putting one more 24. And the quantity of sewage produced during detention time will be 11,520 liters. Now we are going to assume rate of deposited sludge. Okay, so as we have seen that the sludge is going to be deposited at the bottom of our septic tank. So this rate of deposited sludge will be 30 liters per capita per year, which means for one single person for 1 year it is going to be 30 liters. Okay, so cleaning period we can assume it to be, cleaning period will be 1 year. Okay, so this is also we are going to assume this one. Now what is the volume that is going to be deposited, or volume of sludge that is going to be deposited in the sludge tank or in the septic tank, which is going to be 30 into 1 year, that is cleaning period is 1 year. 30 is a deposited sludge, and the population that is given in the problem is 120. So 30 into 120 into 1, that is equal to 3,600 liters. So this is going to be the volume of sludge that is going to be deposited. Now we have to determine the total capacity of the tank. So how to determine the total capacity of tank? One is that we can see that three things are there. So which is capacity of sludge plus capacity of sewage. So capacity of sewage already we have calculated as 11,520, and capacity of the sludge is 3,600. So when we are adding this, it becomes 15,120 liters. Okay, so when we convert it into meter cube, we have to divide this by 1000. So I'll be getting 15.1 meter cube. So 15.1 meter cube is going to be the capacity of the tank. Now we are going to assume the depth of tank. So assume depth of tank is 1.5 meter. Okay, so what is the area actually? Area is nothing but my volume by depth. Okay, in simple I can say that volume is area by depth. So area will be volume by depth. So volume we have determined it as 15.1 and depth as 1.5. So which will give me the area as 10.1 meter square. So as we have seen, our septic tank is going to be a rectangular one. So again assume L is equal to 3B. So what is area actually? Area is L into B. So we have determined our area as 10.1. Length, instead of length I will be writing it as 3B, and in B that is going to be B. So which is 3B squared is equal to 10.1. So my breadth will be equal to 1.8 meter. Now length is equal to 3 into 1.8 meter, which is equal to 5.4 meter. So I can take my length as approximately 6 meter. Okay, so if you see here, breadth is 1.8 meter, length is going to be 6 meter, and depth is going to be our 1.5 meter. So assume freeboard as 0.3 meter. Freeboard as 0.3 meter. So effective depth will be 1.5 plus 0.3, which is equal to 1.8 meter. Okay, so now the tank size will be 6 meter cross 1.8 meter cross 1.8 meter. So this is going to be the answer. So I have uploaded the other subject videos also in the you can see all those links in the description box. Thank you for watching and happy learning.